Hey guys, so today we are going to look at complex numbers. I'm actually hoping that today will be a review for you. You would have learned this in college algebra or even in Algebra 2 at the high school level. If you don't remember it, today will be a great refresher for you. And if you're learning this for the very first time, then I hope I can make this painless for you. So, section 5.1, complex numbers. So, if you remember, you cannot take the square root of a negative number. So, if you were to type in the calculator, square root of a -4, the calculator would give you an error. Because you just can't do it. So, to make up for this, mathematicians created an imaginary unit, which is I. So, the square root of a -1 is I. So, anytime you have a square root of a negative number, you always take out the negative and change it to an I. Okay? So, therefore, when you're looking at this, okay, if I was to take this side and square it, and take this side and square it, you would see that I squared, and then here the square and the square root would cancel. You get -1. And you can actually see that right here. Okay? And so those are the main two things that I would say about this that you need to remember. Maybe one more additional thing as we keep going in the lesson. But those are the main two things. Now, in using this, you can create a complex number. Okay? So, one thing to remember, the real part of that complex number comes first. Back here in the back would be the imaginary unit. Okay? So this is what we would call standard form. So you can see more about it right there. So what we're going to practice is going over the operations. Okay? So as you can see, two complex numbers are equal if both their real and imaginary parts are equal. To add or subtract complex numbers, we simply add the real parts together and then add the imaginary parts. Okay? So if you look here, because this one is a plus sign, I would have just said 3 plus -2, which you can see right here, gives me 1. And then 5i plus 4i, which you can see kind of right there, they just factored out the I and put it on the outside, equals 9i. Now, when it comes to subtracting, I actually do it slightly different. I rewrite my first one, okay? And then what I do is I distribute my negative. So I would actually change this to a +2 and then a -4i. And then I would say the same exact things. 3 plus 2 is 5. 5i minus 4i is an I. Okay. When you multiply, you honestly just FOIL. So you would take 3 times -2, gives you that -6 right there. And then you would do 3 times 4i, which gives you the 12i right there. Okay. Then I would change it and do my inner. So my 5i times the -2, which gives you that -10 right there. And then when you multiply 5i times the 4i, you get that 20i squared. Now, if you notice, if you look at this problem, okay, 12i minus 10i is that 2i. So you can see that. But you have to remember I squared is a -1. So this I squared is going to change to that -1, and you're going to multiply that times 20. So that actually changes to a -20. So therefore, when I put -6 with a -20, that is how we get the negative 26. And notice that the real part is written first. Okay. To divide complex numbers, you must multiply the top and bottom by the reciprocal of the denominator. I shouldn't say reciprocal, sorry. The complex conjugate of the denominator. So, and we will practice those here in just a second. But the reason why we multiply by the conjugate is because all i's will cancel. And that's what we need. We can't have any i's in the denominator. So let's make a note of that and say no I terms in denominator. Okay, so let's go see what we got. So the first one is adding. So we just want to add our like terms together. So we're adding, plus signs don't change anything. So negative 2 plus 4 is 2. And then we're going to say 6i minus I is a 5i. And there we have our answer. Okay, but remember on this other one, I mentioned when we have a minus sign, what I like to do is distribute. So we're going to have negative 7 plus 5i. 2 negatives here make a positive. And then 2 negatives here make a positive. So again, I would just ask myself, what's negative 7 plus 9? 2. 5i plus 11i gives us the 16i. Okay. Okay, so the next little section that we're going to do is multiplying. Okay, so we are going to distribute this negative 4 to everything in the back. So we're going to have negative 12 minus 4i. Then we're going to distribute the negative 8 to everything in the back. So we will get negative 24i. And then we will get negative 8i squared. But remember, like before, this is a negative 1. I'm going to go ahead and bring down the negative on this one. So it'll be negative 8 times negative 1, which gives us a plus 8. So our real part is negative 12 plus 8, which gives us a negative 4. Negative 4i minus 4i gives us negative 28i. Okay, and you guys are more than welcome. Pause the video, see if you can work some of these out, and see if you get the same answers that I do. Okay, so again here, we're going to distribute that 8 to everything in the back. So we get a negative 24 plus 72i. We're going to take the negative 4i, multiply it times everything in the back. So we're going to get positive 12i minus 36i squared. Again, we're going to fix this. This is a negative 1. I'm going to go ahead and drop down negative 36 so that I can go ahead and change this to a positive 36. So negative 24 plus 36 is 12. 72 plus 12 for my imaginary units would give me plus 84i. Okay, let's do it again. Okay, notice how these are the same but different signs. Okay, these are conjugates of each other. Okay, so just something to think about when we go to do those division problems. So notice you have the same thing in the same placements, 2 and then a 7i. One's positive, one negative. Okay, so let's see what happens. 2 times everything in the back. It's going to be 4 minus 14i. 7i times everything in the back would be positive 14i minus 49i squared. So again, oops, didn't mean to change that to that. I squared to negative 1. Drop down that negative 49. Together that makes a positive 49. 4 plus 49 is a 53. For negative 14i plus 14i, notice what happens. They cancel. And that is what a conjugate allows us to do. So our answer is just 53. And notice we have no i's because remember, no i's in the denominator. Okay? D is just a reminder that when you have a squared, you have to write it twice. So this will actually be 5 minus 2i and 5 minus 2i. So let's multiply this one out. So 5 times everything in the back. 25 minus 10i. Negative 2 times everything in the back. Negative 10i plus 4i squared. I squared, negative 1. That's a positive 4, so I'll go ahead and write plus 4 so we can remember. Or, actually, no. I think I'm going to get rid of the positive because we don't really typically do that. So 4 times the negative 1 is a negative 4. 25 minus 4, 21. Negative 10i minus 10i, negative 20i. Okay, so hopefully the adding, subtracting, multiplying is not too bad. Now we're going to go practice the dividing. But here's the thing about the dividing. The dividing is just multiplying. Okay. So remember what I said. We have to multiply by the conjugate. So the conjugate, since this is 2 minus I, we have to multiply top and bottom by 2 plus I. Okay? So let's see what we get. 5i times this gives us 10i plus 5i squared. Now I'm going to have to do this a little backwards because I can't go down. This is a negative 1 times a 5, which means this is a negative 5. So I'm actually going to come over here and rewrite this. This is 10i minus 5. Okay? We'll do it like that. Okay, the bottom one, 2 times 2 is 4. 2 times I is a plus 2i. Negative I times 2 is a negative 2i. Negative I times I is negative I squared. So again, this is negative 1 times negative 1, which gives us a positive 1. So 4 plus 1 is 5. 2i minus 2i, they cancel. Okay, so you can kind of think of it like this when you're dealing with conjugates. You take the first one, which is 2 squared, minus the last one squared, which is I squared. We get 4 minus I squared. I squared is a negative 1. So it's going to be 4 plus 1, which gives us the 5. Now, let's reduce it. So to see it better, I'm going to rewrite it as 10i over 5 minus 5 over 5. 10 divided by 5 is 2i. And then minus 5 divided by 5 is 1. But remember, this real part has to come first. So it's going to be negative 1 plus 2i. Okay? So if you want to pause the video, go ahead and pause the video and try B on your own. If not, let's go get started. So this one says 4 plus 3i on the bottom. So the conjugate would be 4 minus 3i. Okay. So let's get started. 3 times all of this. 12 minus 9i. Negative 4 times 4, negative 16i. negative 4 times negative 3i positive 12i squared. I'm going to go backwards, going up, I guess. I squared is negative 1. Multiply that times 12, you get the negative 12. So let's rewrite it. We got 12 minus 12, that's 0. Negative 9 minus 16, or negative 9i minus 16i is a negative 25i. Okay. Let's go look at the bottom. I am going to go ahead and multiply it out. 4 times 4 is 16. 4 times negative 3i is negative 12i. 3i times 4, positive 12i. 3i times negative 3i is negative 9i squared. But this right here is a negative 1 times the negative 9 changes the term to a positive 9. So 16 plus 9, 25. Negative 12 plus 12, they cancel like we wanted them to. But remember what I said, you could take the 4, square it, minus the second one squared. We'll write it like this because we have more than just the I this time. That would be 16 minus 9i squared. Remember that changes to a negative 1, which changes to 16 plus 9. You still get 25. Now to finish out the problem, negative 25 divided by 25, that can happen. We can reduce it to a negative I. Okay? So notice dividing is actually just a bunch of multiplying, and then just simplify your fractions. Okay? Now, roots of negative numbers. So now we are going to fix them. So remember, the square root of a negative is going to be I. Okay? So we have to make sure we take that out. So think of it like this. Square root of 4 is 2. Square root of a negative 4 changes to square root of a negative 1 times 4, which means the square root of 4 is 2. Square root of the negative 1 is I. So that's the difference between the two. So let's go see what we got. Square root of a negative 81. So that means we have the square root of negative 1 times 9. Sorry, I already changed it in my mind or in my head. So square root of negative 1 times 81. Square root of 81 is 9. Square root of the negative 1 is I. Let's drop that minus sign down. Let's look at the next one. This would change to the square root of negative 1 times 144 because we already know what that is. The square root of 144 is 12. Square root of negative 1 is I. And then notice we can put these together. 9i minus 12i is a negative 3i. Okay? Okay, so let's look at the next one. So we got a little bit more in there. So let's see. We got the negative, and we have an 8. Can 8 be divided by a perfect square? And the answer to that is yes. It's 4 times 2. Okay? So the square root of 4 is 2. Square root of negative 1 is I. And the 2 is left on the inside. But we had a 5 on the outside. So 5 times 2i is 10i square root of 2. Want to go ahead and drop my plus sign. Let's look at this other one. We got square root of a negative 1. 18 can be divided by 4, so the next perfect square would be 9. And that it can be divided by, we'll have 9 and 2 is left over. Square root of 9 is 3. Square root of negative 1 is I. Square root of 2 is left behind. We did have a 3, so we're going to drop it. 3 times 3i would be 9i, and then square root of 2. So notice the square roots are the same in the back, so we can add basically just the fronts. So I don't want to underline that. So 10i plus 9i is 19i square root of 2. Okay. If you have a scientific calculator, trying to remember off the top of my head. I know like a Casio 300 FX 300, something like that. It can help you simplify square roots if you're struggling with them, but if not, just keep simplifying them the way that I'm doing. Okay, now notice that this was adding and subtracting. Be careful when you're multiplying the roots. So let me show you what's going on here. If we have a 2i times a 3i, we get a 6i squared, but I squared is a -1, so we get a -6. However, notice what happens here. If we were to multiply this and use the product rule, which means we can just multiply these together and say -4 times -9, that would give us a 36, and the square root of 36 is a 6, okay? This is if we use the product rule for radicals. Okay? But notice what happens when I take my i's out. If I change this to 2i, and then I multiply that times my 3i, okay, then together I will get my 6i squared. Then I can change that to 6 times -1, and I actually get the -6 that I need. Or I can change it to I square root of 4. Then I can change it to I square root of 9. And then I can still multiply outside with outside, so that would be I squared. Inside with inside would be a 36. I'm going to have to go this way, but I'm too close. Then I would get a -1 times the square root of 36 is 6, and I still get a -6. So the biggest thing is here, you must always simplify the square roots first, then you can go and you can multiply them together. Okay? But don't ever just multiply them. So please make sure you do that first. Okay? So let's go simplify these and then work them out. Now, like I said, you can do them either way up there. Either way is fine. So what I think what I'm going to do is I'm going to go ahead and just simplify them. So I think I'm going to start here. This would simplify to the square root of a negative. Now, 12 can be divided by 4. And then a 3 would be left behind. Okay? So the square root of 4 is 2. Square root of a -1 is I. And then square root of 3 is left behind. Okay? Then we have the square root of a -4. Square root of a -4 would be 2, and then my I, and then minus square root of 2. Okay, so now since we simplified the negatives underneath the radical, now let's go and multiply it out. So 2i times 2i, because they're both on the outside, is 4i squared, and then we have square root of 3, minus 2i square root, and then 3 times 2 is 6. So we do need to fix our I squared as a -1 times 4 is -4 square root of 3 minus, and then our -2i square root of 6. Okay. And notice the real part's written first and then the imaginary part's in the back. Okay, so let's go look at this next one. We need to change this one. So this would be the square root of -1. Now there's not a perfect square that goes into 7, so we're just going to leave it. Square root of a -1 is I. Square root of 7 in the back, and then we have a 3. And I don't have to rewrite that anyway, so let's look at this one. We have the square root of a -1. The 8, we can divide that by 4, so b times 4 and then times 2. Square root of 4 is 2. Square root of a -1 is I. And then our square root of 2 is left behind. But we did have a 2 up here. So we need to do 2 times 2, which is 4i. So I'm going to wrap that up. Guess I could do that too. And then I'm going to rewrite that one so they're on the same line. So now let's go multiply this out. 3i times the 4i, because they're on the outside, is 12i squared. Square root 7 times 2 is the square root of 14. Now 14 does not have a perfect square. It's just 7 times 2. We don't have another option. So the only thing we need to fix is our I squared is a -1 times 12, which would make that -12 square root of 14. Okay, hope this lesson wasn't too bad. You guys have a good night or a good day.